Hey Sage, we're trying to switch over to Patrick's uh meeting. I don't hear you, your mic's not working, but it's in yeah, it's in chat here. I know everything's screwed up. Okay. Really? Uh so you know? Okay. Yep.
Oh, there's nobody here.
There should be 4 people. Isn't
Yeah,
there?
comparatively,
Okay.
usually they're like 20 or something.
Yeah, I know. I'm somewhat regretting even touching the meeting URL because I think it's everyone's.
So this URL is not the one that's in the Etherpad.
Damn it.
By the way.
Okay.
Let me go
All
there and
right.
see if that's where it is.
Well, I know because I think Patrick sent me a different link to. I don't know. I think it's not what it was supposed to be. Yeah, I see that. It's different than the one he sent me as the administrator thing.
Yeah, it's different from the one that you sent it in your email last week.
Yeah. I think we need to figure out which meetings are supposed to be where.
Maybe that one.
Are a bunch of people there? Do we know? I'm loading it up now. It looks like the one that's in the Etherpad is Patrick's personal thing. I think he accidentally linked his personal meeting into the Etherpad because I don't have a moderator code for this one.
Yeah, looks like you're right, but everybody's there.
I know. Okay. I don't know how to start it though. Sage, do you have the magic ability to make this start? Yeah. So he created a meeting, a new perf meeting, so that he could be the maintainer and actually like record the videos for it. No, I think that's the problem is that it's not. Now I need to make sure I get everyone into the. I've got too many Blue Jeans meetings opened up here. I gotta find the right one. Where am I? What am I doing? This one.
Patrick's
This is the one I
You'll
want.
be able to get the passcode from him.
Okay, I'm gonna fix the Etherpad here because I think this other one is the one that we're supposed to be using now. Where the Etherpad went now. This. Slow. I don't think Flash likes having like 5 or something Blue Jeans meetings open at the same time.
All right, that looks better. All right, should we start?
Sure, let's do it.
Should I go through pull requests really quick? Yes. We lost him. We're recording. Okay. I'll do the pull request really quick. The main one that's still in flight is the prefer wall size. I finally have hard drives on my local box I need to hook up today so I can actually test it in a sort of in its intended environment. I'll try to do that today. A couple of pull requests merged. The partial reshard for Bluestar merged, and the blob ref map stuff merged. That just reduces the amount of metadata and simplifies some code. So that's better. RGW's chunk sizes are tuned better. That also went in. The main other thing that's in flight that doesn't have a PR open right now is we realized the fast dispatch stuff was way more complicated than it had to be because of the way that we were dealing with PG splits. So we have a big, long series of patches that fix that. Simplifies a bunch of code, way less locking, less complicated, should be much faster. So that's in the compiling and running state, but not really tested or reviewed. But it looks promising so far. I think that's it for the highlights.
I'm back. Sorry, I think I accidentally closed the wrong window. You just went through the PR stage?
Yep.
Very good. All right. We've got. I guess I've got a couple things here. Last week, I think I've repeated Nick's sync write test results in BlueStore. I think Sage, you're gonna probably take a look at that with your setup now. Mm-hmm. Sage, Greg, and I think Josh are working on code reduction in fast dispatch. Do you want to say anything about that, Sage?
I just talked about it very briefly, but I guess the short version is that it looks very promising and yep, in progress.
Cool.
I'm doing a build right now, so I can send it through some technology tests and see how it does.
Fantastic. I will definitely be interested in taking a look at that once you've got code that works. Let's see. So the past couple of days and over the weekend, I went back and finally crossed something off my to-do list that's been on there for a while, is to get Mark Seeger's get put benchmark into CBT and kind of fix the RGW stuff in there. It sort of worked already, but not in a really convenient way. So now you can use CBT to stand up a cluster and run get put benchmarks against RGW. So that's fantastic. Good news. It makes benchmarking RGW a heck of a lot easier. So I'm going back now and trying to look at some tests that were run by our reference architecture team at Red Hat, where they were seeing kind of poor scaling on a fairly large cluster with RGW. They were using EC62 bucket indices on hard drives only, but they were using NVMe journals. with 1x replication on a very small cluster in NVMe drives, I could easily do better than they were seeing. I was getting like 10 gigabytes per second, and they were seeing about 2.5. Now that I've switched over to actually making the OSDs do more work, trying to replicate their EC setup. I think it's 4+2, not 6+2, but I'll have to check on that. But anyway, I'm seeing quite a bit lower performance. I've also now replicating the index pool though with using 3x replication in the index pool. So also seeing very, very high latencies. So something's going on. I'll need to dig into it more, but definitely something interesting there. In the 1x case, though, I can push about 3.7 gigabytes per second through one gateway. So that's good news. It's really, really CPU hungry. It was using like 20 cores. A lot of that seemed to be in the TCP layer. Though perf it's kind of hard sometimes to interpret what perf is saying. So it's possible that this was tied up in lots of like threading work and such. But it seems like most of that is eliminated by using high TC-malloc thread cache values. I wouldn't doubt, though, that there's still a lot of threading overhead going on. Yeah, I guess that's about it for Radius GW testing. Hopefully I'll have more in the next week here. But yeah, that's it for now. Is anyone from Nokia here? We might have lost them in the craziness with the meeting URL today. It looked like they added something on here about seeing a 2x write improvement with Debian WoW on SSD, but I don't actually know what that means. If adding those onto an SSD gave them a 2x write improvement, or if it tuning gave them a better write improvement. But anyway, maybe next week though I'll talk about that. They're not here to talk about this week. Does anyone else have anything that they would like to talk about this week? Not hearing much.
Hello?
Hello? Yes.
Hi, this is Jian Jian. I'd like to talk about some funding about KRBD and NBD in our container environment.
Mm-hmm.
Yeah, basically we want to we compare the KRBD. Initially, we use KRBD in our bare metal container environment, and our kernel was 3.10, and which is quite old. So we wanted to use some new feature in librd. Then we tested librd with NBD, and we found out in our test environment and for our test case, we found out NBD and librd actually is about 10% faster than KRBD. But in other test result, posted by community, we saw people are saying NBD and librd is 10% or 20% slower than KRBD. So we like to know, what's the latest update on that. And
my guess is it's going to be related to the workload. The main difference is the KRBD has no client-side caching, so the IOs are going to go straight through to the OSD. Whereas if you do NBD to librd has a client-side cache, and so some of those writes will return immediately, and then they'll only block when you have a flush. And so depending on the workload or the benchmark that you're using, you might get better performance because of that client-side caching.
Sure.
So
by the way, for the client caching, that's in-memory caching, and so for both NBD and KRBD, they both of them on client side they have a page cache. So
yeah, it depends on the workload. So if you're doing something like DD, then kernel RBD is going to be slow. But if there's like a file system sitting on top, then probably you're going to have pretty similar behavior.
I see.
But it really depends. It depends on the timing of and the overlap of the IOs that are being passed to RBD, whether they're blocking or not. Because in the kernel RBD case, those IOs will tend to block, whereas in the librd case, they won't block until you get a flush. And so it has to do with the IOs, the writes versus the flushes, and so on. So it's hard to. There's no sort of simple answer, I guess.
Just to add to that, oh, sorry, Serge. I know that also a lot of the older kernels, there was problems with TCP no delay, which was fixed in the later ones, which had a large impact on performance. And then there's also a lot of read ahead improvements in later kernels as well, if it's some read stuff as well.
Yeah, thanks, Nhi. Yeah, we saw that, yeah, but we didn't notice any big performance impact for TCP no delay. Yeah, we're not sure why. Yeah, we are using 3.10. Supposedly, we should see the performance impact of TCP no delay, but we didn't see that. Yeah, very interesting. Another question we have is whether we need to go for our cluster. We kind of want to know whether we should go for NBD and or KRBD. We want to know whether NBD plus librd is the right choice for us, or we should go for KRBD.
Yeah, I think that the main thing is that NBD is probably not sort of the going to be the most common choice, and it's not the primary focus for the RBD team. Instead, they're looking at using the LIO TCMU runner, which is a different sort of user space pass-through that's part of the LIO stack, and attaching librd to that. So that it's the same basic concept where you have librd running in user space, and it's exposing a kernel block device. But it's instead of using NBD, it's using the LIO TCMU runner thing. I'm not sure exactly what the status of that is. Maybe Josh, maybe you know more. But that's the path forward. That's what they're going to use for doing iSCSI support and for in general. That'll be the recommended choice if you want the latest feature set, basically.
Yeah, I think right now there's still a few bugs to be worked out in the TCMU layer, so they're getting those fixed up. But so those are performance bugs and correctness bugs too. So it probably shouldn't be used just quite yet, but it's like pretty close, I think.
Are there any details anywhere on kind of what the trade-offs were, or why we went one way versus another?
I think the main one is that NBD is sort of dead and unsupported, particularly notably in Red Hat and CentOS kernels. It's not supported at all. Whereas LIO is well maintained and more featureful. The other reason is that the LIO pass-through is SCSI based, which means that all the reservation information gets passed through, which means that we can actually do proper HA failover fencing stuff with the iSCSI, multiple iSCSI gateways, and that isn't possible with NBD because it's sort of a dumb protocol.
Cool.
I see. So we have a cluster which we are going to have Ceph in production within 1 month. So we need to use a KRBD in that case. Okay.
I would recommend using either NBD or KRBD, but just keep in mind that in the future you'll want to migrate to using the TCMU thing if you go the NBD route. For the short term, it's probably fine to use it for now. I don't think there's any known issues with it, but yeah.
I see. Thank you, Sage.
So, Josh, is there any timeline for the TCMU support for?
I'm not sure exactly. I'm unfortunately not too up to date on this myself. You have to ask. You can ask on the mailing list, perhaps.
Yeah.
Okay. Hey, so there's another question for the QoS for the IO pass in the Ceph. So I was wondering, so far, what's the status of QoS support?
It is an ongoing saga. So there's a prototype of DM clock. It doesn't work very well because of several reasons. The main sort of focus right now is the main known issue is that the queue depth effectively below that queue in the object store layer is very deep, and so it doesn't really matter what the QoS layer decides because it all just gets stuck in this big long queue anyway. And so we're trying to figure out how to automatically tune that lower level queue so that we don't have to manually tweak options for every specific disk or SSD or whatever. And that's what we're working on right now primarily. And the hope is that once that we have sort of a handle on that, then we can sort of demonstrate that the DM clock QoS stuff is working in the higher layer. But we have to sort of solve the first problem first. So that's for the sort of featureful DM clock that lets you do reserved I/O for clients and so on. There are other efforts that are trying to manage this sort of at a macro level just by carefully controlling how IOPS are provisioned by limiting at the client side and making sure that you don't oversubscribe the cluster. And that's stuff that happens in like Cinder, basically. And I think those are totally separate from Ceph. In fact, actually, they don't really even depend on Ceph at all. Sort of admission control, I guess. And that's an option probably if you're depending on what your environment is.
Yeah, so far we have a situation like we have probably more than 1,000 or 2,000 clients access their Ceph cluster one pool at the same time. We try to make sure each client is going to have their own, their provisioning in terms of IOPS, or even I'm not sure for sure we cannot do the latency, but at least the IOPS.
Yeah, well, I mean, the simple thing is to just throttle all the clients. So if you give each client 100 IOPS or whatever it is, and you make sure your cluster can do more than 100 times however many clients you have, then they won't step on each other. That's the easy thing. And there's nothing preventing you from doing that today. So QEMU already has its own sort of client-side throttling that you can configure.
Okay, thank you.
Yeah.
By the way, do you guys have any internal discussion in terms of QoS development?
There's a weekly call where we talk about sort of the ongoing development stuff that I just mentioned. If you want to participate in the development activities, then you can join that.
So I can send you can you send me their email list? Or?
Sure. Yep. It's a development discussion though. It's not like, can I use it yet? And does it work? It's trying to solve the issues with the code.
Okay, cool. Thank you.
But yeah, if you just send me an email, I can invite you if you want.
Sure. Thank you.
All right. Anything else?
I don't have anything here unless if you want to briefly mention Dan's thing that he sent.
Oh, yeah, that's sort of performance related. So there's this crush issue with small OSDs or small racks or hosts or whatever getting more PGs than they're supposed to, and it's sort of a thorny statistics problem. And Dan presented it to one of his like weekly groups at CERN, and a couple of people came up with a solution or a proposed solution. So that's promising. Share the link, I guess. But I have to figure out if that's actually going to work or not. We'll see. But hopefully. hopefully it's promising. It does. This solution does mean that the small OSDs get fewer primary roles than the others, which is not totally ideal, but it's better than getting too much data. And maybe we can post process and correct for that. So we'll see. Let's see. So I guess the main thing really I think going on right now is this the fast dispatch refactor, which I could talk about in detail, I guess. Although I mostly want to talk about it with Greg. He's not here right now. But Josh, if you want, I could go into detail and make sure that the queuing.
I'm here now.
You are? Okay.
Yeah, let's go into detail.
Let's do it. Okay. All right. Let's see. I guess I can post the branch. GitHub.com. It's whip faster dispatch. This is the branch in the chat. I don't know if there's a way to show a diff of like. So this branch is built on top of the feature stuff that's ready to merge. And then there's a second batch that's the whip PG split stuff, which basically makes the changes so that clients will resend. If it's a new OSD with the new feature bits, it'll resend a request on a PG split, whereas previously it didn't do that. And it adds the bits to the monitor so that it will force old clients to resend on a PG split also. So that's sort of the second half of this. And there's some cleanup in MOSDOP to make it all work in HObjects and a bunch of other stuff. So that's nice. The other sort of main takeaway is that the MOSDOP message gets a SPGT, which is the placement group ID and the shard number encoded explicitly in the message instead of having to sort of infer that. Because previously it had the full hash value and you had to look at a current OSD map to figure out which PG that mapped to on the server side. Now the client is putting that information in there. And so the end result is that every message that's coming into fast dispatch now has the SPGT, the exact placement group shard that it's destined for right there. And so we can just pass it directly into the queue. And the queue is basically just search and replace refactored to use PGIDs instead of the placement group pointers. And so that's great. The fast dispatch path is like one. Let's see if I can find the actual, tree. It's super, super simple. Source OSD, SCC. Maybe I can even share my screen or something here. I can browse the code. Application window. Here. That's fast dispatch. The fast dispatch basically this is coming directly off the messenger, and as long as it's either not an OSD app because all the other messages already had the explicit ID in there, or it's a new client that understands that it has to set this explicitly, then we just queue it directly with no further checks or work or anything like that. Otherwise, if it's a legacy client, then we have to do some checks. So we have to look up a map and do that mapping. And we do this in order to preserve ordering. We have to do this waiting on map thing handoff, which it's very similar to what we did before. But basically, those functions get fed through here. This function, and we basically say if it's the client has an old map, we maybe share it. If the map is too new, the client has a newer map than the OSD, then we can't process it yet because we don't know which placement group shard to pass it to. But if we do, then we actually do this mapping to the actual placement group shard, and then we queue it based on that. And that's pretty much the entirety here. So the fast dispatch loses all of that crazy waitlist that was based on PGID and had to be smart about splits and all that crap. Basically, only for old clients, we have to look up the current OSD map, and we have to do that mapping. And I think actually I'm missing a lock here. There's supposed to be, this is like the one place where, oh no, it's here, it's in the caller. So we actually do the service get next map reserved and release map, this like annoying complicated handoff that's in OSD service. And it's really just to run this one function. And this one function is like not doing any blocking work. It's not taking any locks. It's just doing mappings and calling in queue. So I think actually we can vastly simplify this reserved map and release map to be something much lighter weight. Once this all works, then I think we can optimize that part too. But the end result is that it should be much faster.
That was not in the legacy, or is that in the legacy code path, or is that the?
It's only in the legacy code path.
Okay. Yep. Okay.
Pre-Luminous clients are going to go through this path, but I think we'll be able to make it faster than the old code path, even so.
Okay.
Yeah. So it takes a per session lock, which won't be contended because this is the thread that's processing it, whatever. And this one map thing, which I think we can reduce. We can do some atomics and some spin locks and something and make that a little bit easier. But anyway, the end.
I would be surprised
if we can make it better.
In particular, yeah, like that machinery needs to keep being careful as long as it's present. In particular, Dan did a thing to switch all this away from using locks to atomics and spin locks, and it was slower. So
yeah, he did.
Like,
he did the
increased number of memory operations.
He did the RCU thing. Yeah.
Yeah.
Yeah. Well, yeah. So we'd have to make sure it actually helps, but it's a much smaller scope of work that's being done under the protection of that map, and so I think it's more hopeful than it was before. but yeah, it probably doesn't matter anyway because it's legacy client. So,
Greg, do we understand why it was slower? What he did and what parts of what he did were slower?
No.
Okay.
I don't think
lock-free algorithms require a lot more memory barriers. And if it's low contention, then that's expensive compared to a mutex.
Is that a guess or was that measured? So
that's a guess, I think.
Yeah.
But I think it's a pretty safe guess.
I heard it secondhand, but I'm not sure how much performance data they had on it.
Okay.
That's what Sam told me, though.
Yeah. So anyway, that's the fastest patch gets really simple. It's just this waiting for map on sessions, and the wake up stuff is simpler as a result. And so I'm pretty happy with that. But what it means is that everything that gets queued, if it's a legacy request, it always has an older map than we have, or the same or an older map. But if it's a new client, it could be a newer map or an older map. We don't know, which means that we're going to have things coming out of the bottom of this queue that like are PGs that might not exist that we need, or they're old for old PGs that went away a long time ago. And so the second half of this has to be much smarter. So that is in sharded work queue process, which I cleaned up a little bit. So basically it comes through, it peeks at the item, it says, it basically puts it on the ordered list of things that it's going to process, and then it drops the lock and tries to lock the PG because it has to do that first so that it's ordered within the PG lock. So it tries to look it up. This may or may not happen because we may or may not have the PG, because we now item.first is now PGID instead of a pointer to the PG. So this may or may not work, but we don't really care yet. We have to go grab that item that we had queued, so we're ordered. So if we have the lock, then we have this in order. If we don't, but either way, we have the item dequeued and we're ready to go work on it. And we have to handle the case where the PG doesn't exist. And so this is a little bit different. Sometimes this is an op that came out of fast dispatch. Sometimes it's not, which is also sort of annoying and confusing. But in this case, there's a new set of wait lists that's just called waiting for PG. So there's a mutex that protects just the waiting for PG map. And it is a map of SPG to a list of PG queuable, I think, which is a thing that comes through the queue. And so we look and we say, if the sharded placement group in the current epoch that is protected by this lock, so this waitlist is basically always maintained in synchrony with a specific OSD map. So this OSD map reference is protected by the lock also. So if, as of that epoch, that PG should exist on this OSD, but just doesn't, then we'll just wait for it. We just haven't like created it yet, or we haven't gotten a notify to instantiate the PG or whatever. If it's a fast dispatch op and the client has a newer map than we have, then maybe it doesn't exist yet as of the OSD map we have, but it will in the future. So we also should put it on that list and wait for us to catch up to that map, and then maybe we'll decide to create it or not. And otherwise, it's like an older map or whatever, then the PG shouldn't exist and we just drop it on the floor. And that goes away. And then there are a couple other checks then. When we process a new map, we go through and look at all these, where is that? Date map in here. Then publish. I have to find this. It's here somewhere. Yeah, dispatch sessions waiting on map. Oh, that's the other thing. Oh, here it is. Yeah. So we look at we go look at the people after we have our new map that we just processed. So the OSD is catching up. We go take the lock. We update the one that it's sort of synchronously matching, and then we go through all the things that are waiting. And if it's something that we shouldn't have, then we throw it out. This is actually wrong because I think if the requests there are from the future, then we have to keep them. So we actually have to. Okay, so this is wrong. I just wrote this code yesterday. So I think we need to make sure that this list is paying attention to sort of the newest epoch that the client had. And if it's in the future, then we make sure we keep it around at least that long before we are able to throw it away. Does that make sense? Craig?
Yeah.
Okay.
Sorry, I'm dialed in, so I can't see the source, but that sounds right. What I would be worried about is that we want to make sure we're not losing the thread locality properties we used to have. And I couldn't tell from the description.
Yeah, it shouldn't be different in the general case, because the only difference is that the queue is passing a placement group ID through instead of a pointer through, and lookup's happening at the other side. And all this complexity is dealing with.
As long as we're allocating it to the correct thread, then that'll work.
Yeah. Before it would take the PG pointer, look up the PG ID under the pointer, and then use that to pick the shard. And now it just already has the ID and it just picks the shard. So it's not that much different, right? It's here. The shard index is now it's in NQ. Before we had a PG pointer and we had to go take its whatever, and now we already have the ID. But either way, it's still calling hash to shard on the same thing.
All right.
And then the last result is that the all of the checks that used to happen before we queued something about whether the OSD or the client had like an old map and needs a map update, or the request is old and it should get thrown away. All that happens now after. So there was a whole waiting for map thing that happened before things get queued, and now that's all in the PG instead of in the OSD. And so the PG has a new waiting for map thing. That's sort of the first gate, the first thing that things might sleep on. And so in do request, I think it is. Yeah, isn't it? Do request. Do. That's a primary. Yeah, so the first thing now in the request handling is checking whether we have to wait for a map. And the behavior here is equivalent to what happened before, where if there are any ops already waiting for the map, then new ops also wait for the map so that we preserve ordering. And we only start waiting if we get a request that has a map in the future, in which case we just start populating that list and wait. And these other tests we're already here. Yeah, so it's really, these are the only new ones now that are happening post queue. And then I changed requeue ops so that if we are sort of pushing stuff back up into the queue backwards, if there's stuff that's waiting, then we has to go on that list in order to preserve the order instead of going back up and all the way up into the OSD work queue. So it's pretty similar to what happened before, but the ordering stuff's a little bit different because it's happening post instead of pre-queue. And as part of that, because it was so freaking confusing, I actually went and documented all of the or map. Oh, it's not in this particular version, but I went and documented all of the different places that ops can wait and the properties, because some of the lists sort of were waiting, and then once we stop waiting, we never wait on them again, like the waiting for active and waiting for peered. And other wait points can start waiting and then stop waiting and then start waiting and stop waiting, like scrub. And that because of those different properties, you have to deal with requeuing differently in order to preserve order. So I actually tried to document all that in one place so you can understand why the code requeues everything in a specific order in the places that it does, which is better, I guess, than what it was. It's still kind of gross. So I'm sort of trying to figure out if there's a better way to structure the code so that it's a more verifiable, safe framework for handling requeuing stuff that is better able to preserve order. But I don't know, we'll see. But that's, yep, I guess that's the short version. It runs well enough to like start the cluster and like do IO and mark things up and down, but obviously it's not complete. Since the first time I looked at that function, I realized it wasn't quite right. So, yep.
Hey, Seth. So how much performance improvement do you expect from your new?
We haven't measured it. Don't know. All we know is that the previous code had like 5 different locks that it was touching, and it was much more complicated, and it was spending as long as like 50 microseconds in this part where it's just trying to get stuff onto the queue. So my expectation is that this is going to be, hopefully tens of microseconds faster. But it's also just way simpler. So even if it doesn't result in a performance gain, I think it's a big win, but I'm pretty sure it'll help.
Okay, cool. Thank you. Okay, thank you.
There were definitely cases where it seemed like fast dispatch was hurting us in tests that I've run, so I'm hopeful too that we'll see something from it.
Yeah, it might be stable enough to repeat some of those tests, but
I'll wait for you to get the locking in order.
Yeah, the waiting for map thing is clearly wrong. I'll go fix that first, but yeah, I don't see. Yep. Anyway. Okay. Any other questions?
Hi, Sid. This is Jian. I have a question about the PG distribution, which is related to the OSD weight, which you were talking about. So James posted our issue on mail list. So basically, we found out in our cluster we have the PG distribution is not that even for each OSD, and on the OSD which has more PG, we saw bigger latency on that OSD. So that's why that's why we saw the big latency tail as well. And we are thinking about how to adjust the PG numbers on each OSD manually. And one team members proposed to use OSD way to adjust the PG numbers. But then we saw this bug, which smaller OSD might get more PG, more data. So
yeah, that's a different issue. So I wouldn't worry about that yet. That happens if you have like racks. Each rack has like whatever 1,000 OSDs, but then one rack has like 2. Then it's going to get those OSDs will get overloaded. But that's not usually the situation. So I wouldn't worry about that for now. The main thing you want to do is there's a command that will adjust all the OSD weights automatically in order to even out the distribution. It's Ceph OSD reweight by utilization. If you run that, it will adjust the weights to converge the usages, utilizations.
I see. I will do that. Yeah, I will try that. Thank you.
Reweight by utilization.
So
there's also reweight by PGs that you can do also. Reweight by PGs, which is the same thing, but it looks at PG counts instead of bytes stored. They're usually more or less equivalent, but.
So this is reweight by utilization command. We will try to rebalance the PG once again after the cluster is set up.
So the reason to use reweight by PGs is it goes by PG counts, which are accurate at the time you create it before you put any data in the cluster. Whereas reweight by utilization looks at bytes stored, and in order for that to be effective, you have to actually write a bunch of data to the cluster. And after you do that and then you reweight, then it's going to move all that data around again. So I would generally use reweight by PGs for a new cluster, and then maybe reweight by utilization for a aged cluster.
I see. How frequent this we should run this reweight by utilization?
You generally only need to do it if there's a change to the cluster. Like if you're adding or removing OSDs, that's when you need to repeat the process. But the easiest thing would probably just be to run it from a cron job daily, because if it's already been done, it's a no op. So there's no reason not to just keep doing it.
I see.
Sage, does that look at all the PGs across all pools, or is that do you
yeah? So this assumes that your cluster is sort of uniform in that you're distributing your data across all OSDs. If you're doing tricky things like having certain OSDs doing just SSDs and certain pools mapped only to them, and other pools doing just OSDs, then the utilizations will be different between those sets, and it's not smart enough to really deal with that. It can deal with some parts of it, but not the whole thing. So you have to be careful.
And potentially too, if you have weirdly imbalanced pools, right? Like one pool is skewed one way and one pool is skewed another way, you could end up like with non-local optimums, right?
Yep. So the plan is to move this functionality into the manager and make it more sophisticated. So there's actually one of the Google Summer of Code projects is going to be to do this in the manager, because there are various people have written offline scripts that do the same thing. That are smarter, basically. And so the hope is that we'll sort of do that.
Sure.
Yeah. And my doorbell just rang, so I got to run.
All right. Oh, we're out of time anyway. So, any last minute questions before we go? All right. Have a great week, everybody. We'll reconvene again next week, and hopefully we'll have some more info on all these interesting things that are going on. So, back to you later, guys.
Thank you, Mark.
Thank you, Mark.